Good morning, afternoon, evening. This is lesson three for this week on frequency trees. So today we'll be looking at how to represent and interpret outcomes using a frequency tree. Okay. Um, Frequency trees are linked to two-way tables. They're also linked to probability trees. They look similar to probability trees, so they can sometimes be confused with these. All right. To access today's lesson, you're going to need the following equipment. You'll need a pen or pencil, some paper, and a ruler as well. So, what is a frequency tree for? Um, a frequency tree is a diagram that helps you show how information is categorized. So usually it will accompany, a paragraph or maybe a few sentences of information. So, similar to a two-way table question, it might say there's 100 people were asked whether they like Marvel or whether they like DC films, and 60 of the people were women and 40 of the people were men. And these are the answers. So you've got enough information there. You've got two branches, two sets of categories. You've got male, female in my example, and you've got Marvel, DC. And so you end up with branches on your frequency tree. Okay. It can be used to help find probabilities, as I said already on the title slide. It might ask you at the end of the question. So part A might be complete a frequency tree. Part B, common part B question would be something like, what's the probability if I pick somebody at random, I choose a male who likes Marvel films, using my example. So how would you display this information in an easier way? 30 students were asked if they liked coffee. 20 of the students were girls. 6 of the boys liked coffee. 12 girls did not like coffee. Use this information to complete a frequency tree. Okay. Now you may have read that question, and before you read the last line, you may have been thinking it's quite similar to what we did in the previous two lessons, and you'd be right. This could have been a two-way table, because as usual with two-way tables, you've got two variables. You've got girls and boys. So that's one of the variables. That's a gender, and then you've also got liking or not liking coffee. So that's your second variable, and that is it could be a two-way table question, but obviously with this question it tells you complete a frequency tree. Okay, so let's look at how you do that. First thing you need to do is plot out your frequency tree. Okay, now it will look like this. So you've got your initial starting point. You've then got your first branch, which in this case is girls and boys, and then off of each of those two, you've got a second branch, liking coffee, not liking coffee, and then repeated liking coffee, not liking coffee. So two branches because I've got two variables. Girls, boys is my first branch, and then like coffee, don't like coffee, don't like coffee is my second branch. Now, in terms of filling it in, very, very straightforward. Look at the question, read it fully, okay? Don't just read it partially and start, jumping into conclusions or anything. Read it, write the information down that you've got. So, 30 students were asked if they like coffee. So straight away, I can put 30 as my starting point. 20 of these students were girls. So I can put 20 in here. 6 of the boys liked coffee. So on the boys branch, 6 go in the like coffee circle. 6 go there. 12 of the girls did not like coffee. So don't like coffee, I've got 12 there. Now that's all the information the question gives you. However, I hope you can see we can now work out the rest of the information. So looking firstly at the boys, now assuming as we do in this sort of question, well with this question specifically, that there are no gender neutral students, if there are 20 girls and 30 altogether, the other 10 must be boys. Okay, so 20 and 10 because it has to add up to 30. Now, again, same sort of principle. If 12 of them don't like coffee, the only options on the questionnaire, on the survey I gave them, was like it or don't like it. There wasn't any other option like, oh, I think it's all right, or I have it some days, or I might drink one if I'm working really hard, it's late at night, or something like that. So there's no options like that. It's either you like it or you don't like it. Then it must be 8, because 12 add 8 makes 20. And similarly down here, 6 add something has to make 10. Answer is, of course, 4. Okay. Here is another bit of information for you to try and work, create a two-way table for. So you've got 56 students were asked if they watched tennis yesterday. 20 are boys. 13 didn't watch tennis. 13 of the boys, sorry, didn't watch tennis. And 17 girls watched tennis. And the question is for you to draw a frequency tree to represent that information. Please pause the video now and press play when you're ready to see the answer. Okay, so we start with 56 as our starting point. Our first branches, boys and girls, we've got 20 boys, which means we must have 36 girls because that adds up to 56. Next, 13 boys did not watch tennis, so 13 there. And if 13 didn't watch it, then 7 must have watched it. And then the same over here, 17 girls watched it, which means it must be 19 who didn't watch it. That is the answer to this question. So there's my completed frequency tree. Well done if you got that right. I'll give you another one to have a go at now. Please can you pause the video and draw a frequency tree to represent this information. Have a go now. So just running through the answers then. Starting point, 85 were asked what they did for lunch. 47 were girls, which means it must be 38 boys. Now, 5 had a packed lunch, so 5 goes there. 21 of the girls had a school dinner, so I've got 21 school dinners. 13 girls had other, so maybe they had, I don't know, a snack from break, or maybe they nicked some food off their mate, or maybe whatever. So that's 13 that had other. And altogether we know that 40 pupils had a school dinner. So if I've already got 21 school dinners amongst the females, and I know it has to add up to 40, then there must be 19 school dinners amongst the boys. Okay, and I also know, of course, that these 3 add up to 47. So I've got 13 there, and then using this bottom line, 40 had a school dinner, 21 here, so it must be 19 there. And then the final bit of information is the other. So 5 add 19 is 24, so I need another 14 to make 38. Okay, a little bit harder this one because there were 3 options, but it's the same basic idea. Read the question carefully, fill in what you can. Here is an exam style question. I want you to pause the video and have a go at this. So 90 children went on a school trip. They either went to a field or a river. There were 43 boys, 20 girls, and 21 boys went to visit the field. Complete a frequency tree. And part B. Use the diagram to find the probability that a random child chosen would be a girl that visited the river. Have a go at that now. Press play. Pause the video and have a go. Press play when you're ready for the answer. Okay, so the answer, as you can see, it's got to be 47 girls and 27 went to the river, because I know that 20 went to the field, adding up to 47, and similarly there. Use the diagram to find what's the probability that it would be a girl that visited a river. Well, I know the denominator is going to be 90. How many girls visited the river? The answer is 27, so final answer to that question is 27 over 90, which you can simplify because they both divide by 9, 3 over 10. But leaving it as 27 over 90 is fine, unless the question tells you you must simplify your answer. But this question didn't, so that or that is good enough. Okay, here's the main task for today's lesson. What I'd like you to do, please, is to complete, if you're in set 1, both of these questions. If you're in set 2, just the red question. So just that one question, okay? We've done a few already as part of your sort of your turn, my turns. So you've done a few. Just one more for you to really embed this, make sure you're clear on how to do it. As always, take a picture, upload this onto ClassCharts to complete today's remote learning. And I'll say again, if you're in set 1, I want you to do both of these questions. This one here, a little bit harder because there's a ratio involved, okay? Good luck with that.